that's an important piece. Now, while he has the versatility in this construction of these multi-tenant technology centers, he mentioned power, the power consumptions and the power profiles. That's a point I want you to put a pin in it. Hunter and others will come back and to make the distinction between data centers and what we're building here. That'll be an important learning point for you today. I'll let the experts get that treatment for you, though. All right, well, our next speaker. This individual brings new dimension to the term, taking it to the streets. As the founder and CEO of TOWARDEX Technologies, James Jun pioneered the nation's first large-scale carrier-neutral meet-me street underground conduit network, and of all places, Boston, Massachusetts. If you can do it in Boston, no offense to the New Yorkers, you can do it anywhere. This led to the digital ecosystem that empowers network operators and fosters market competition with no monthly recurring cross-connect fees. Put a pin in that one, too. That'll be another one that our esteemed colleague Hunter will litigate later today. He also founded MassIX. That's the largest carrier and data center neutral internet exchange in New England. And no offense, folks, I'd have to say he wins the prize for the best photo from the in the field category of our speakers today. Ladies and gentlemen, Mr. James Jun.
Well, thank you so much, Tom. It's a real pleasure for me to be here today, so thank you, everyone. So I'm here to we're going to talk about building physical infrastructure for connectivity in the era of AI. Just as a quick intro of who we are, I mean, Tom did a fantastic job, thank you. So we started, whoops, sorry, is there a way to whiten the background there, or is that?
We put it into their colors.
Okay, yep, no worries, yeah, I forgot I said that. All right, so, so who we are is, so we're network engineers, we're network nerds, and we love the internet. And we love this so much that in 2012, we decided to start our own ISP. Because no offense to existing carriers who you'll see some of our lovely partners there, we love them all, but quite frankly, they kind of sucked. So we ended up starting our own, and we're a B2B provider. We also do tons of dark fiber between data centers, the usual, the data center ecosystem. So we're very popular amongst what's called a co-location customers. So co-location customers are enterprises that would take lease space in data centers to house their servers, the GPUs, what have you. Next. And then we've become New England's peering central. So just a quick recap on what peering is for some of you that may not have heard it before. So, and peering essentially is the exchange of data between different internet networks. And the more uniquely peer you are, so it's interconnections, right? The more uniquely peer you are, the more shortcuts there are in your network, what we call routing tables. So that's like the map that your devices have to push the traffic. So we exchange in our city, where I come from, in Boston, when customers are using their internet bandwidth from us on our network, we exchange over 90% of all the New England traffic locally in Boston. We don't relay it through New York. When we started TOWARDEX in 2012, it was the opposite. The 90% of all traffic, street to street, or if you have a colleague in the business next door, it's all going through New York or Chicago. It was pretty horrible. And we also started MassIX. So why did we start MassIX? So MassIX is an internet exchange that's a switch, or what we call switch fabric. As we've run our, built our network, provide connectivity services, our customers are very happy. That's great and all. But we can always talk about how great we are, but that's just sales pitch. So what we wanted to do is, how can we make more network? How can we make this performance available and open to as many networks as possible? So that resulted in us starting the MassIX, and to really enable our partners and our friends to also be able to interconnect directly in Boston without any fear of dealing with all these performance problems and things like that. So where do we go from there? We didn't stop there, because so far everything that we did was just network guys doing configuring routers, switches, optical, all the fun stuff. But then as we continue to expand our business, we realized that all of this is all just, at the end of that, all this technology relies on one thing: it's physical infrastructure. If you don't have physical infrastructure, can't really do anything. So what we did is, in Massachusetts, we built the nation's first underground interconnection utility. So instead of people bringing their fiber to a specific address or location of building, and then getting charged to connect between each other, we've created what's called the underground meet me street, where instead of meeting only the buildings, you can now do so right out in the street. So the result is, so a lot of times when we talk about interconnections in the internet, we generally talk about what's called network gravity. So as the more and more carriers, more participants come in, this marketplace, this ecosystem of different actors, if you will, that are exchanging traffic together, that it's kind of like the innovation campus here. It keeps drawing more people in. So that so far in the internet used to be what we used to call landlord-controlled infrastructure. So when you want to build a regional, network gravity of interconnections, we always had the prevailing idea is that we always had to do it in the buildings. And then what happened was, over time, we call carrier hotels. These carrier hotel guys, they realized that, oh, there's so much economic activity, let's tax them. And that became the form of what's called the recurring cross-connect fee. So in Boston, we've gotten to a point where the recurring cross-connect fee costs more than the connectivity itself. So it really started inhibiting a lot of the high bandwidth needs of our customers and the industry partners. So we decided, well, let's do this. Let's even the playing field. How about we allow other new data centers to come in and compete? And the way we did that is take that meet me business, put it outside in the public streets, and all of a sudden, it just flipped the whole game. So, this is what resulted today, and it's pretty funny because usually when you order telecom circuits, you call the carrier and say, hey, I need a telecom circuit from my office address here to a carrier hotel like 1102 Grand in Kansas City. You need what they call AZ locations, the either ends of the circuit. And what ended up happening in Boston is a lot of these carriers are all getting confused. They're getting all these requests to deliver services out on the street, and they're like, what's the address? So it's pretty wild seeing that in action with our customers for sure. So the internet, as just to briefly touch on, as we all know, runs on physical infrastructure. And I think many of you will be surprised. Even a lot of people in our industry, in the data center space, IT space, even many of them have really no clue about this. Now, why is that? So normally when you look at a carrier hotel or data center development, half the time, these guys focus a lot on what costs them a lot of money and engineering. That's power, cooling, those are very costly items. But then they also, connectivity, my phone works, it's in the cloud. So, and they completely neglect and forget about the fiber, and then after the building's built, it's all nice and shiny, they figure out, well, why is there no bandwidth around here? So it happens so many times. But here in Wichita, that's not what we're gonna do. So we're talking about AI-ready networking. When it comes to AI-ready networking, dark fiber is the currency of everything, and I'll tell you why dark fiber is so important. So just a quick recap. When you want to have a private line, like from say, like here we are in WSU, from this building to say Shocker Studios, you call a carrier and say, I need 10 gig line or 1 gig line or what have you. With AI, the connectivity needs are so much that a single carrier cannot possibly provide you that connectivity service at the rate that is economical for you. So what dark fiber does is if I'm a carrier, instead of me selling you a 10 gig line or 100 gig line, which, of different unit speed, and I'm essentially restricting your capacity by charging for how fast the line is. Instead of that, I'm giving you, a pair of unlaid fibers that were put in the ground, but nobody touched it. It's just sitting there in the ground. So now suddenly the customer is now the carrier. So if you want to do 100 gig, 400 gig, or 1.6T, whatever you want, you don't have to call the carrier. That's between you and your network guys. So, but with dark fiber, what dark fiber needs is physical infrastructure. It's real estate. Whether it's even if it's a public street, it needs space. Wires have to be hung on poles or they have to be in conduits. And that brings us to this. So this is a typical telecom manhole, and it's actually, don't laugh, it's actually one of the nicer ones. I've been to about 100 ones. This is actually one of my favorite ones that actually have the least problems working in. But manholes are very critical. So when we look at, a lot of people, when people talk about connectivity, broadband deployments, we always talk about challenges with pole attachments, but very rarely do we talk about manholes. And the reason is because a lot of the manhole infrastructure is usually done in what we call shared use or joint trench environments. And what that means is When you're deploying broadband on a horizontal scale, you got to hit as many homes as possible. Aerial poles and what you deal with poles is going to be the majority of your expense and where you're going to be spending time in. However, when you're building vertical infrastructures, like what we're doing to the carrier hotel, interconnection hubs, the IXP of the world, you need density. And the only way you're going to do that securely and scale is underground. So then, all of a sudden, the manholes start looking like this, and it turns into a complete disaster. And the unfortunate thing is, as you could imagine, infrastructure congestion makes everything very expensive. Because you look at this manhole right now, so there's someone's what we call splice cases, a box in one. That's a network carrying critical traffic for FAA and everybody in Boston. Yeah, just think about that. And so you got all that going on. And when the next guy wants to come out, new dark fiber provider wants to come in and say, hey, I want to compete, I want to provide fiber for half the price as everyone else. And then they find out I can't pull my fiber, I can't even get to the conduit. It's a complete mess. So then this new provider does is they call the carrier, the existing carrier that installed that manhole, who owns and is responsible for managing the manhole. Hey, I can't pull my cable, like what are we gonna do? And the first reaction the carrier does is like, oh gee, sounds like a you problem, right? And then they start thinking amongst themselves, why are our manholes so dirty? And then at some point they're like, yeah, we probably need to clean this up because this is becoming a problem. But then the other guy in the room says, oh, hold on, wait a minute. This is actually a feature, not a bug. Our manholes are blocking competitions. So I will tell you right now, this is not what we're putting in Wichita. We're not gonna do it here in Wichita. This is a city of innovation and engineering, and we don't do that over here. So I'm gonna show you what is coming to Wichita. This is what's coming to Wichita. It is state-of-the-art, organized, and digitally managed and visible infrastructure. So this is not AI generated, this is an actual manhole in the streets of Boston. And it's got a floor, it's like a basement in a building. It's like, literally, from the street, it looks like a sewer manhole. You're like, oh yeah, it's just typical. You open it up, everyone's like, oh my God, what the hell is that down there? So when we're talking about AI-ready dark fiber and scaling that up, what we need to really discuss is we have to guarantee access. We have to be neutral, and we have to guarantee access to as many players as possible. A manhole system like this is more than just tunnels and tubes underground. It is an economic engine. So IXP facilities like this, infrastructure, are frequently accessed by crews working for many, many different carriers. So multi-tenancy and neutral access are the critical guiding principles anytime we're designing systems like this, and the system that we'll be designing here for the CNIXP that's going in Wichita today. And as discussed before, cable clutter and network congestion is, that's the number one, one of the biggest cost drivers of deploying new fiber in shared infrastructures like that. And finally, when you do want to clean this up, the manholes that get put, these large shared manholes, they constantly fill with groundwater. I mean, it's underground, it's below the water table. And it's also got the road grease, the traffic oil, you got all this mud and muck coming in. By the time you're done, about 3 months after it's been, it looks nice for like a couple of weeks, and then after that, start cables going in. Everyone's like, oh my God, this is disgusting, I just want to get out of here. So then what you end up is, every manhole essentially turns into an unmanaged garbage dump where nobody can manage it anymore. So in order to have a scalable infrastructure that is manageable, you have to start with, it has to be completely watertight. You have to hermetically seal it. You have to treat it like it's a building. And we'll go to the next one. And in addition to that, clean infrastructure, as we could all imagine, is a safe infrastructure. Our philosophy in operating our manhole system and the way we're going to partner with the folks here at Wichita to bring today is safety, operational reliability, and digitalization. So digitalized register and maintenance log are very critical. So any work that's happening in the manholes, anytime a conduit gets open, there's a digital permit that tracks that conduit. And when the conduit is closed, that is also tracked digitally in the system for follow-on inspections to make sure the water doesn't come in and things like that. And then we're also going to be using Vision AI. Think about that. There's concrete walls, pipes, and wires, and there's AIs coming into that. So we're going to be using Vision AI to actually conduct field inspection and permit to work audits. So what that allows our, in Boston, what that allows our crews to do, and what that's going to allow the crews here in Wichita to do, is instead of all this stuff going to the back office and someone just, eating snacks in his office that's not doing any work, they're gonna start off with, take a picture with your mobile phone, you upload it, and the system thinks, and it gives you initial score, and then it reports that to the, reports back to our back office for the final approval. And lastly, on this point, maintainable infrastructure is very key for safety as well. At the end of the day, these manholes may look nice, and a lot of people say, oh, I can eat off the floor, I can sleep in there. But no, these are dangerous infrastructure. These are confined space, legitimately. So it's very important that we maintain this infrastructure in a very manageable and clean fashion for safety as well. So the most important is we're gonna completely eliminate free-for-all activity. Everything that happens in these manholes here in CNI-XP are gonna be tracked digitally. So there's no, like, when the carriers come in to put their cables in, there's no like, oh, let me just put the cable there. No, we're not gonna allow that anymore. Every cable that goes in before the cable gets run will be visualized in 3ds Max and AutoCAD, where it has to be pre-designed in advance. So you don't just get to hang the cable in whatever rack that you find. You have to run it accordingly to the plan. And the other thing is disorganized activity in the manholes is strictly prohibited and also enforced. So going back to that Vision AI and the permit to work system, so when we have approved contractors in the manholes, when they fail the quality standards, then they get a warning. And when they fail again, they get a warning again. And the third time, they're out. They cannot work in the system anymore until they take a field training program to, essentially certifies to us that they're not gonna do that again. And so this is an example of a splice case. So before in that disastrous mud hole that you saw earlier, quite the difference. It's every tenant, every carrier coming in here, it's like just inside a building, they get a spot. This particular carrier is only allowed to occupy that spot. It's mounted, it's racked, it's always accessible. And the conduits that are coming to wall are completely sealed up. There's no water ingress, no gas ingress. So these are always sealed, and you can see these QR codes that are also used to digitally track the progress and any kind of work that's happening on these conduits. And anytime crews are in the manholes, there are signage that are guiding them not only for safety, but also for quick reference. They can put up the as-built drawing and inventory of conduits just by taking a picture with their mobile phone. Cable slacks are pretty, difficult to work with always. So the slacks, coils, they have to be mounted in their designated spots, and we try to organize them by the band radius of the cable. And as you can see, every cable that's running through the manholes is digitally designed, tracked. Every cable here has a digital ID that's in the back office system. We don't, there is, a cable that is undocumented and run without a permit is absolutely not permitted. So how are we going to build all of this? So we're going to be leveraging precast construction. Precast is very important because what you're doing is you're digging this confined space, if you will. You don't have a lot of working space. By going precast, it allows us to design to visualize the whole thing in 3D, give that to the precaster, and then they come up with a shop drawing. It allows us to create a completely, precision engineered piece of infrastructure. So right here as an example, this particular slab is a roof slab that will support traffic. So in this particular port, our engineers specified double layering of the rebars without getting too technical, but the spacing, all that is very important. By partnering with Precaster, our engineers get to fully verify all of the quality assurance and the design specs before the concrete goes in. This right here is a wall where the conduits come in. So one thing that we never allow contractors to drill holes or make a cut in the wall. That's how water gets in. Every hole, they have to use a pre-provided holes that are already manufactured into the manhole. The rebars between the conduits are also very important. And then what it looks right now, this is before the concrete is poured, and then what happens in the after shot is this is how it looks after, smooth, clean, white concrete. So how do we install this? Obviously, you first dig a very large hole, just like and you put some gravel padding, and then you bring out the boom cranes, and I love those cranes. So it's like a Lego block. You lift it up and you just drop in the hole. It's real easy, quick, safe, right? So here's another one going in there. That's another one. That's a trench box. That's you can see the boom train. The boom crane, the spreader. It's after it was put in, and then Yep, there's another one, and then finally. And this is how it looks after it was just put in. You can see the cable racks, the sump grate, the cantilever arms for managing cables, all that good stuff, and the signage that are being put in before. And this is another manhole, so it's a larger one. That's what we call meet me hole, where the splice cases go. This is literally the day they was put in, and you can see the conduits, the pipes haven't even arrived yet. The following day, the crews, brought in the conduit, so this is immediately after it was put in. And this is the finished product. It's clean, organized, how it looks from the entry point. There's no garbage or any of that allowed down there. And there's, another picture of the conduits coming in. So if you ever wonder how internet looks like or how it should look like, you're looking at that right now. And, and I gotta say, I am so proud to be here and to partner with Wichita on this project, and I will tell you why. As I discussed, I may have touched on this briefly, IXP infrastructure is not just manholes, conduits, and fibers. It's economic engine. Now, when we're in fiber business, and a lot of people, everyone talks about how large of a fiber are you, how much fiber strands are you putting in? For us, we don't care about fiber strands at all, and I'll tell you why. That's an old, antiquated way of thinking. When we're talking about IXP, all we care about is how many cables can the infrastructure support. We care about cable count, not fiber count. And the reason for that is every cable is a tenant, it's a carrier, it's a business, it's a department at WSU. Every cable has an owner that represents endless economic possibilities. And that is what we're trying to empower everyone. We want all of our customers to come in and say, you don't have to spend, hundreds of thousands of dollars doing expensive dig, go through all the permits. Dig once. We put a big system at once, make it accessible, make it neutrally administered, make it clean, and the customers come in, and all they gotta do is they just gotta, bring your own cable. That's all you gotta do. So we're going from what we've created. What we're going from is we're going from the old landlord-controlled infrastructure, the carrier hotels that are charging expensive fees, and with CN IXP, we're now moving to the era of operator-empowered infrastructure. And that is how we're gonna scale for AI here in Wichita. And this is gonna be the first greenfield deployment after what we've done in Boston. All these beautiful pictures that we've built in Boston are really, it's really a reaction to all the chaos that's going on there. So just think of it as more of an upgrade. But here in Wichita, it's gonna be greenfield, and we're very excited to be partnering with you, with all of you. And not only am I excited to work with all of you, I'm also excited to learn a lot from you guys as well. So, and that's the other part.